Okay, log on your calculator. It says log. We assume that's log with a little base 10, all right? If you notice here, in this first example, it's not log base 10, it's log base what? 4. So if you don't know how to do the change of base, or some of your calculators just don't do it, there is a little formula. And when I say formula, it's the easiest thing in the world. Look at the log base for 25. Everybody see that? See how it's set up? Okay. The log is base 10 on your calculator. So what you're doing is you're changing it from log base 4 to log base 10. And the way you do that is you write the word log. Everybody with me? We're going to write the word log. And it's log of the number. So log 25. Then you hit divided by log of whatever the little base is. And then you hit enter in your calculator. That's it. It's log of the number and then log of the little base. And that changes it for us. So when you guys do that in your calculator, what's log 25 divided by log 4? 3.32? 2.32. Okay, yeah, something like that. And I'll tell you what to round to. Right now, 2 decimal places is fine. We're going to do a lot of rounding when we do solving because we're working with exponential stuff that doesn't come out nice and pretty. But if I... Uh-huh.
Why don't we put in... I know there's an option where I can put in log 425, but...
Okay, go ahead and do that. What do you get?
Let me...
That's what I was just saying. Some of your calculators do this for you. Some of them don't. So if your calculator doesn't, just depends on the model. And if you don't know how to do it, then this is how you would do the change of base. All right, same.
Okay, that really works.
Okay, same thing here. How would I do this in my calculator if I did not have the change of base formula on my calculator?
Log 12 with the log of 2.
Good. Log 12 divided by log 2. And what do you get?
I got 3.58.
3.58. Same in here, guys? Okay, perfect. Yep. Okay, go get it. All right. Exact same thing here, but it's telling us to use what?
A natural log.
Natural log. On your calculator, what's the natural log button? What does it say? ln. Same thing, guys. If I was going to change using natural logs, I would say ln of 25 over ln of 4. And what do you get?
You get 2.32.
Isn't that what we got the first time we did this?
So that's what
Yep.
you
Okay.
use this in Excel.
Same thing if they tell us to use natural logs, I would say ln of 12 divided by ln 2. Enter. What do y'all get?
3.58.
There we go. Okay. So that's how, and you'll see tomorrow when we do some solving, you're going to have to do something like that in the solving process. So just so you guys know how to do it.
Miss
When,
Meadows, for our homework, like, how do you want us to show our work then? Should we just like?
This is enough.
Okay.
Like even if you have a calculator that does it for you, if you just show me this step to say, oh, okay, I understand what number goes on top, what number goes on the bottom, that's fine.
Okay, thank you.
Yeah, sure. Okay, guys, when we talk about expansion and condensing, okay, this is actually a very simple concept. It can get a little confusing, but you guys are going to be okay. I have plenty of faith in you. If you notice, logarithm with base, natural log, it's the same thing. It's just one has a log, one has an ln, but it's the same process. What you guys need to remember, okay, what we need to remember, what is going on right here between u and v? Multiplication. And what's going on with it over here? Adding. You need to remember that multiplication goes with addition and vice versa. If you're starting, well, we'll talk in a second. Multiplication goes with addition. Addition, multiplication. What's going on in the second one? What do you see? What's happening between u and v? Division. Good. I have division. And what is division going to go with, guys? Subtraction. Good. If you can remember these tiny little things, I promise you this won't be as hard as it appears. And then the last one, what happens with the n?
It looks like instead of
Where is the first n?
it's in the exponent.
It's in the exponent. And then what happens when we change it? It goes to be where?
Like the growth factor.
Oh, out in front. But what do we call that when we have a variable or a number out in front?
A coefficient.
A coefficient. Remember that exponents become coefficients and coefficients become exponents, depending on what we're doing. If we're condensing, if you're going to condense something, you're making it what?
Smaller.
Smaller. If you're going to expand something, you're making it what?
Bigger.
There you go. That's the whole concept right here. All right, these first couple questions, you guys are going to be like, wait, what? This doesn't make any sense. You'll have something like this on your web assign. We're not going to put this on the test because this is just getting you guys to think a little bit. But it says to write each logarithm in factors of 2 and 3. Okay? So I can rewrite ln of 6. You guys agree? I can rewrite it as the natural log of 2 times 3.
Yeah.
Right? Everybody agree with that? 2 times 3 is 6? So if I have my natural log, what is going on right here? What operation is happening?
Multiplication.
Multiplication. So if something's being multiplied, that means we're already smushed together. I'm going to pull it apart. And it'll tell you on your test or quiz, it'll say to condense or expand. But what operation goes with multiplication?
Addition.
Addition. So if this is already smushed together and I want to pull it apart, I would rewrite this, or I could rewrite this as the natural log of 2. What?
Plus the natural log.
Plus the natural log of 3. Do you see how this one was smushed together and this one we pulled it apart? When you smush together, you only have like one ln out in front, or one log. When you pull it apart, every single little piece gets the ln or the log. Just a matter of smushing, pulling apart, smushing together. Now again, they want us to use factors of 2 and 3.
Play-Doh.
Uh-huh. Question? Deanna?
No.
No, gotcha.
No, I was just commenting.
Oh, sorry, my bad. Okay, so look, if I rewrite this as factors of 2 and 3, can I break down 2 at all?
No.
Okay, so this is 2 over, what can I break 27 down into so it's a factor of 3?
3 cubed.
3 cubed, good. Now, this is already condensed because I only have ln written one time. We're going to pull it apart. So there's 2 things you guys need to see here. What do I think of when I see this right there?
Division.
Division, okay. So what does division go with?
Subtraction.
Subtraction, good. And I see an exponent right here. What does an exponent become?
A coefficient.
Yep. I didn't even come close to spelling that right. You guys know what I mean. So when I rewrite this, I'm going to pull it apart. Every term is going to get its own ln. So just like you guys would read this 2 divided by 3, that's how you write it. The 2 comes first. So I would write the natural log of 2. And then what does that division bar mean?
A subtraction.
Subtraction. And look, you can do this 2 ways. Some of you are going to say, can I just? Yes, you can. But I'm going to rewrite this as the natural log of 3 cubed. Is this completely expanded and pulled apart? Is everything linear?
Wouldn't you have to put the 3 as a coefficient?
Yes, this 3 needs to come out here. To be fully expanded, it would be the natural log of 2 minus 3 natural log 3. Some of you will skip this step. You'll just put the 3 in the front. That is perfectly fine. But all we're going to practice doing today is smushing things together and then pulling them apart, and vice versa. But on your web assign, they will ask you. Some of them, I think one of the questions, it says like, break down using factors of, I don't know, 5 and 6. Or 9 and 2, whatever. That's just what they're asking you to do. Just use factors, like they said, 2 and 3, to figure out what the numbers are, and then pull apart or smush together. We okay? All right, let's go. We got a couple more examples, and then that's it. I have 5 examples. All right, it says use properties of logs to expand each expression. Sometimes it'll just say expand or condense. Look at this problem. Is this already smushed together, or is it pull it apart and we have to smush it back together.
Oh, it's already smushed.
It's already smushed together. I see log 4 written one time, and then everything else is being smushed together. So before you guys even start, you should be able to look and say, okay, I have 5x cubed y. What's going on between the 5, the x cubed, and the y?
Multiplication.
Multiplication, okay? So when I see multiplication, when I'm pulling it apart, I think what?
Addition.
Addition, good. When I see that exponent of 3, exponents become?
Coefficients.
Coefficients. Now, you don't have to write every step like I'm going to. I'm just going to write every step out so you guys can see it. But I'm going to rewrite this so log 4 goes to every single thing in here gets a log 4. And since they're all being multiplied together, when I pull it apart, plus signs go in the middle. So I'm going to rewrite this as log 4 of 5 plus log 4 of x cubed. Then I'm going to say plus log 4 of y. Do you see how it was smushed together? It was condensed with just one log, and then when we expand it, we pull it apart, each piece gets a log. Now at this point, some of you would already have written the 3 out in front of that log 4, but I want to just show you step by step. Look at this. Is everything linear, meaning is everything all on the same line? No, I have to bring this 3 out in front of this log. So when I rewrote it, it would be log 4 of 5 plus 3 log 4x plus log 4 of y. Questions? Did you guys get to this last year in Algebra 2?
I think so.
No,
Okay.
I don't. Not in my class.
Okay. That's okay. That's fine. No big deal. No big deal. Let's look at B. B is already smushed together. They want us to pull it apart. The first thing I see is that division bar. So what does division go with? Subtraction. Okay, let's remember that. Now, square root. Those are kind of, this will work, guys, for everything. If you have a square root, cube root, fourth root, something like that. Can I rewrite, I'm going to rewrite this, B, ln of, can I rewrite 3x minus 5 using an exponent?
Yes. Half.
Good.
Half in front of the ln.
I can say, hold on. I hear exactly what you're saying. Just, you're going a step ahead of me, Vincent, but good. I'm going to rewrite this as this. If it was the cube root, what would the exponent be?
1/3.
1/3. If it was the fifth root, what would the exponent be?
1/5.
1/5, okay? But now I'm going to rewrite this. And again, I'm going to write out every step. You don't have to write out every step. But every piece gets its own ln. So the numerator gets its own ln. ln of 3x minus 5 to the 1/2. What did you tell me division went with?
Letters?
Yes?
Why is it 1/2 instead of 2?
Because if you have the square root of something, there's a little index here. So I had 3x minus 5 to the first power. Your index becomes the denominator, so it's 1/2. If you have the square root, it's not the same. It's the opposite of squaring a number. It's not the same as. Good question. All right, so guys, I have my natural log of 3x minus 5 to the 1/2. What goes right after that? Minus what? Natural log 7. Is this completely expanded?
No.
No. What's the one thing I got to do? Take that 1/2 and put it out in front. 1/2 natural log of 3x minus 5 minus the natural log of 7. Now, I'm going to tell you right now this is done. But somebody's going to ask me, well, wait a second. You have minus that 3x minus 5. Do you see how 3x minus 5 is in parentheses? It's in a hug. Leave hugs alone. Don't break up a hug. I mean, now obviously in COVID times we do. But don't break up a hug. I used to tell my kids in Atlanta that there's no divorce in logarithms. 3x is married to -5. They're stuck together forever. You cannot break them up.
You tell how many old twins that Logarithms.
Not my actual biological children. I call all of you my kids. I've been teaching 16 years. How many children I have? It's crazy. My kids in Atlanta. I had seniors. No, Reagan and Valentina don't care right now about logarithms. Although in due time, Valentina's going to be teaching me stuff. She's so smart. All right, so that's expanding. Now we're going to do just the opposite, guys. We're going to take these problems and we're going to do what with them?
Condense.
We're going to smush them together. We're going to condense. Now, it looks like a lot, but if you just kind of take a second to say, okay, A, let's look at A. When I see 1/2 and when I see the 3, what should you immediately think of?
Combine them, make them 7/2.
No.
Oh,
Those
wait,
are
wait,
coefficients.
together.
Coefficients become what? Exponents. If I were you, I would just go like this. Look, just remind yourself. Oh, that's right. Coefficients become exponents. When I see this addition sign, what mathematical operation do I think of?
Multiplication.
Multiplication. You guys can do this, and it makes your problem easier. Do they both have the same log? So I rewrite that how many times? One time. I'm going to write log 10 out in front. And now I'm going to go in 2 steps just because I think it's, well, yeah, I'm going to go in 2 steps. So I have x to the 1/2, right? Plus x plus 1 to the 3rd. Can I smush that even more?
You could, like...
If I started off with addition in my problem, what should we turn it into?
Multiplication.
Multiplication. So this is the same as log 10 of x to the 1/2 times x plus 1 cubed. One more thing I would like you to do, guys. What's another way I could write x to the 1/2?
The square root of x.
Yeah, I would like you to write the square root of x times x plus 1 cubed. Now, some of you are going to say, now do we simplify that? There's absolutely no reason in the world for you guys to write out x plus 1 3 times, multiply it all together, and then distribute a square root of x in there. Please do not do that. Just leave it. That's fine.
Does that also count as a hug?
Yes. You've already smushed it all together. Don't worry about doing anything else. But you really and truly can save yourself a lot of time and a lot of stress if you look at the problem at the beginning and think, okay, what am I looking at? All right, look at letter B. B has the natural log. Is it natural log and natural log?
Yes.
Yes. Okay, so the first thing I see is that 2 out in front. That 2 I know is going to go where?
Exponent.
Into an exponent. And when I see subtraction, I think it should turn into... So we can write the natural log one time. And would you guys agree with me that this would be x plus 2 quantity squared over x?
Yes.
Okay. Can I cross out the x's?
No.
No. X is not the same as x plus 2. So that's it. All we're doing is smushing together and pulling apart. There's your answer. All right, there's a lot going on in the next one. But that's okay.
No.
That's
I'm
a,
not done writing. Wait.
okay. I'll wait. You're okay.
These also the 1/3 power?
Yes.
Oh.
Oh, what does that mean? The 1/3 power.
That means they're all cube rooted.
Cube root. Not they're all. The whole thing is. I like that you said that. Do you see where this 1/3 is, guys? It's in front of the entire thing, right? So I can take this and I can put it back here. It's going to go back there. What?
Would we have to, like...
Hang on. Hey, whoa! Don't steal my thunder. This is I get to do this. Wait a second. Wait. You guys are killing me. What's up? Good question. Nick said, how come in the first one The 1/2 just went on the first log, but in this one it went on the end because look, this 1/2 is just out in front of this. This notation on the second one, or this third one, Nick, do you see how it's telling you 1/3 and then the whole thing's in brackets? Good question.
Oh, I see the brackets.
Very good question. Yeah, I covered it up when I circled it. Hang on. Okay, so I'm going to rewrite this as log 2, correct?
Yeah.
Okay, so I have 1 log 2. And then what do I have in my parentheses?
You have x minus 4.
What about this one? Or what's left in my brackets? I'm sorry.
Oh.
What does this mean I have to do with those two terms?
You multiply them together.
So I have x times x minus 4. And you guys told me it was all raised to the what?
1/3 power.
To the 1/3 power. Now, technically that is correct, but I want you to go one more step. I want you to rewrite this as log 2, and then underneath a big cube root. So x times x minus 4.
Put it as 1/3 bracket log 2 x minus 4. Is that
Like here.
yeah.
Now, once you do that, you have to go that next step to distribute it.
Okay, and then just put it all.
Yep, just put it all in there. Yep.
Then you never put a log under a.
Nope, good question. Annie said, do you put the log underneath the root? No, the log always stays out in front. Good question. Guys, that's it. That's all condensing and expanding is. You just have to practice. Your WebAssign is practicing going from big to smushing it together, from smushed together to pulling it apart. It's just practice. That's it.